DBMS. So here DBMS is nothing but database and management system. Management system. So here, what do you mean by database? Database is nothing but collection of data. So here management system is nothing but managing the data. Managing the data. So what do you mean by data? Data is nothing but an information. Information. So what do you mean by information? Information is nothing but getting data by investigation. So this is about the DBMS. So in DBMS we have two systems, the database and management system. So in this database and management system are the software which is used to store the data. So what do you mean by data? Data is nothing but an information. So in information we are getting the, how we are getting the information is getting the data by investigation. By doing investigation we get the information. Okay. So in this DBMS, introduction to first concept is introduction to or history of DBMS. Introduction to DBMS. So how it was introduced, by whom it was introduced. So we are explaining here. So in early 1960s, Charles was introduced IMS. So what do you mean by IMS? IMS is nothing but information management system. Information management system. So in the late 1980s and early 1990s. So the IBM was developed DBA, database administrator. So database administration is nothing but a collection of data which is in the database. So this is the history of DBMS. Next, going to DBMS characteristics. So DBMS characteristics are nothing but data independence, next data integrity, efficiency, and recovery, storage, security. So in detail we are going to an explanation of data independence. So data is dependable in database management system. So what is the advantage of data independence? Means one data is depends upon the another data. So the data is related to another data. So that is the independence of independence. Next, data integrity. Data integrity is nothing but data which is independentable to another data. We are calling it as integrity. Efficiency. Whenever we are going to store a data, we are choosing the database to store the data. That is the efficiency. Recovery. Whenever we crash a system or whenever we power up the system, the data is saved or not. By using that recovery, we can get the information. By storage. So if data is, I am having large amount of data, so wherever I have to store, in DBMS we can store the large amount of data. Next, security. So for that data we need to give them security. So we need to provide the key, or we need to provide the log. Some different types of logs we need to provide. So next, coming to an entity. So here we have some keywords in DBMS. So we need to mention in DBMS we are going to have some structure. We are having an ER models. We are having different types of models. So in this we are going to an ER model in this entity. So entity is nothing but it is like noun. It is like noun. So why we are calling noun? So noun is nothing but person name, place, thing. So noun is nothing but person name, place, thing. That may be noun. So in entity is also nothing but noun. So entity set. So what do you mean by entity set? Means it is a collection of entities, collection of different types of entities. So to join the entities we are going to have a relation. So what do you mean by relation? Relation is nothing but showing the dependencies between the entities. Showing dependencies between entities. Okay, this is about the ER model. Here in this DBMS we have concept data models. So we have data models are 5 data models. Data models are 5. So first one, high level data model. Second one, low level data model. Third one, relational data model. Fourth one, relational object oriented. Data model. Next, fifth one, relational to ER model. we are having rows and columns. So columns are nothing but attributes. Columns are nothing but attributes. Rows are nothing but tuples. So in this DBMS, the ER model we converted to relational model. So whenever we are going for ER model, the next one is relational object oriented data model. In this relational object oriented data model, we are having the relations among the objects. So that we will call it relational object oriented data model. Next we are having an ER model. So ER model is nothing but entity relational data model. So here we are having the words entity and relational. Entity is nothing but a noun and relation is nothing but an the data is among the entities and entity sets. We are calling that ER model. Okay. Next concept is DBMS advantages. So what are the advantages we are having in DBMS? So the databases we are using in hospitalization, hospitals, railways, reservation centers, hotels, schools, some different types of extra places whenever we are colleges or universities. These type of examples we can give for an advantages of DBMS. Why we are giving in DBMS as advantage means we need to store the bulk amount of data or large amount of data in database. So that database are called, collection of databases are called, we are having a database server. So the database is used to store the information of large amount of data. Next concept is DBMS architecture. DBMS architecture. So coming to this architecture, we are having the 3 levels of architecture is there. So first level is user level, second one database, second one query. First level is database, users. Second one is query. Querying process. Third one is database server. So here we have native users, application programmers, administrators, users. So this level will be an users. So next level is an application programming, querying process, down we are having DB server. Here the users will connect it to the this is a query process. Next one, this is a server. So coming to the users will communicate to the application programmers. So application programmers will develop the queries. So at what type of queries the users wants, which type of data it is. So according to users, they will communicate to the application program interface. By application program interface, it will go to the buffer manager. After that, we can process the query. After processing the query, we want to get the information. We want to get the answers by file manager. After getting the information, again it will send to it is a bidirectional process. So it will send the file manager to buffer manager. Then buffer manager to the application programming interface. After that, the application program interface is used to send the information to the native users. So this is the bidirectional process from the DB server to native users. So it will have the actions bidirectional. So the query will process the users and it will solve by the DB server. After that, it will go to the native users. So this is the bidirectional process. This is the DB structure. So here in DB structure we are having two types of structures. So coming to next structure, we are having a levels of structures. So we are having 1 tier, 2 tier and 3 tier like that up to so on. N tier, 1 tier, 2 tier, 3 tier up to so on N tier. So what is this means? So 1 tier, it has an application of in this concept 1 tier, so only it communicates with the only one level. It has only one level to give an architecture of a DB. So this is about the first 1 tier architecture. Next, second 2 tier architecture. Here we are having the 2 levels to communicate with the database server. So like that, so on up to n levels we are having. So like that we are having n levels. We are calling as entire architecture. So 1 tier, 2 tier, 3 tier and up to so on entire architecture. So next concept is data abstraction. Data abstraction. By the concept name itself only we are abstracting. We are hiding the data. So data abstraction is nothing but we are hiding the data. So in some situations we hide the data. Okay, this is about the data abstraction. Next, coming to data independence. Data independence. Data independence. So in this data independence we have 3 layers. So first one is application layer. Second one, physical layer. Second one, third one, logical layer. So when going to a diagram, application layer, physical layer, logical layer. So here the data independence is nothing but whenever we are changing the data in a different types of layers, so there is no dependable to a DB server. So it won't affect the server. So when we are changing the application layer, so the data will be changed in application layer means that there is no effect of DB server. When we are going to a physical layer, if any changes are made, is nothing but if we are deleting data, if we are inserting data, if we deleted the unwanted data, so the data whatever you have performed any type of operations will not affect on the DB server. So this is called as data independence. Okay, this is a data independence. So the next concept is this is one of the topics of in DBMS. So what do you mean by file system and what do you mean by database? So in file systems we cannot store the large amount of data. Coming to our database, we can store the large amount of data within a secured manner. Right? Next, in file systems we cannot provide security to a large data. So in database we can provide the security. Next we can recover the information in database. We cannot recover the information in file system. So file system is very less and the database is having more space. Efficiently we can retrieve the data in database. We cannot retrieve the data not in efficient manner. Next, we can get information in database. We cannot get the information in file system. So file system is very less efficiently we require but database is efficient to retrieve the information from the database server. This is about the difference between database and the file management system. So the next concept is ER model to relational model. So how we are converting from ER model to relational model? So here, what do you mean by ER model? ER model is nothing but entity relation. It is showing the relation among the entities and the relation. So what do you mean by relation? It is a connection between the two entities. So for example, we are taking a student entity. Student entity, the attributes are SID, SNAME, phone number, address, parent name. So we are having different types of attributes here. We are having different types of relations here. So how I am converting from ER model to relational model? See, whenever we are converting a ER model to relational model, the attributes will be in columns. Attributes will be in columns. So that entity name should be a table name. So the entity name should be here. A table name. Next one, the attributes are SID, SNAME, phone number, address, email, and parent name. So by this we can get the ER model to relational model. ER model to relational model. So when we are getting to a relational model, we need to insert the data to a relational model. So why we are converting means when we are going to ER model, we cannot insert any type of data. When we are going to a relational model, we can insert the data to a table. So it looks like a table. So we can insert the data so much, how much you want, and it can easily we can store. So for example, Sona, address Hyderabad, so like this we can create the data. So how much you want data, that data will be created by the relational model. So this is about the conversion of ER model to relational model. So next topic is languages of DBMS. Languages of DBMS. So for every particular software we are having the DBMS languages. We are having here DDL and DML. So DDL is nothing but data definition language. So DML is nothing but data manipulation language. To retrieve the information, we are using DML. So to insert or update, we are using DDL commands. So what do you mean by DDL? Means data definition language, which is used to insert or update the database. So here we are using different types of commands to insert, to update the data into a database. So DDL commands are create, alter, update. By these commands we can insert the information, we can insert the data into a database. So create